We have a few questions from the current one, and we'll also follow up with questions from yesterday. But maybe there are questions from the hall. No, not right away. So one of the questions posed was, Section 551 of the Geant4 Application Developers Guide cautions against using different cuts per region, saying that it's only for people with very complex geometries or who are experienced in simulating electromagnetic showers in matter. Could you speak to the caution a little bit more, perhaps with examples of what to be careful about beside the obvious?
We need to review this place. It is obvious misunderstanding. We design cut per region, especially in order to be used in applications. For HEP experiments, it is normal because you have different requirements in vertex detector. For example, when you have micron accuracy of measurements, or in York, where there is a big slab of support structure to support detector. Of course, there you don't need to have the same cut as in vertex detector. So it is very natural that for HEP experiments, there are different devices. In each region, you have different requirements for accuracy simulation and the different cut range. And as I have shown, to define a cut, it is very easy technically. You use UI commands. Of course, if you have a simple setup where you may use one cut for everything, but I would not say that we non-recommend to use different. Of course, a cut for each volume, which are different little bit, may have no sense. But in general, we suggest that you divide your detector or your setup on regions which have different requirements and define for different requirements, different regions, different cuts. Technically very easy.
Maybe I will supplement that, having two volumes right next to each other, in which one you define one micron and you find the other 1 meter, do not really make too much sense either, because secondaries will not be created in one volume that could bleed into the other one. So that certainly possibly what you expected was the obvious, but things that are slightly more subtle than that would also potentially limit your accuracy as well. There's a more specific question: scoring energy deposition in micron-sized sensitive volumes in silicon. That is the application, where energy loss fluctuation. Sorry, which energy loss fluctuation model is more accurate, the Urban model or the PAI model? So again, in micron-sized sensitive volumes.
The PAI model is more accurate, definitely. And it was shown in many applications that PAI model for different conditions out of the box provide correct fluctuation of energy loss. Urban model, we have such a rule. You need to be sure that in sensitive detector, your particle make at least 2 steps. Then urban model become more accurate for sampling fluctuations. But urban model have limitations on accuracy because it's parameterized, and you cannot have very small steps. You cannot have very big steps in order to have accurate description with Urban model. But in average, it may be, result may be decent. For 1 micron silicon, I would either ask Urban model make 2 steps or use PAI model.
Thank you. So there's a couple more questions. One is for lower energies below 2 MeV, for radiological applications with condensed history models, would you recommend EM standard option 4 over Livermore or Penelope? Is the main difference only the ionization model?
Yes, you are right, but at the same time, in option 4, ionization is partially taken from Penelope. Bremsstrahlung is more accurate. So they are very similar. It is not easy to find out application when Penelope, Livermore, and option 4 will be different. There are such applications, but they are very, very, very similar.
The next question is a bit multi-pronged, involving both EM processes and particles and processes from yesterday. The application domain is PET detector simulation in Geant4, and the user wants to simulate isotopes that emit a prompt gamma and positron. And of course, the positron then annihilates to 2511 kV gammas. And they want to record detector hits. So they say one approach is to place the isotope at rest and let Geant4 handle the decays, but in the past, they've had trouble assigning detector hits to the corresponding primary particle. Likely their own limitation. The alternative would be to hard code each particle, prompt gamma. I guess would be to generate both particles, prompt gammas, 511, with separate particle guns. What approach is best?
Recently, we introduced
Vladimir?
Sorry for this robot which started to speak instead of me. Recently, we introduced so-called model ID approach. This means that depending on which model produce given secondary, it has a different ID. If we look into process, sub-process ID, this approach for many years is well established and is working fine. For model ID, we may miss something, but we are trying to do our best. So we subdivide sub-models which produce, let's say, for example, if we have nuclear de-excitation and we have emission of gamma ray, or we have internal conversion and we emit electron from this internal conversion, or we have radiative decay, we should have different model ID for final particle. But I would say that in concrete case, probably it is needed to discuss whether these IDs will work for your application. So in order to use it, an advice, take the recent versions of Geant4. If you cannot distinguish what kind of secondary gammas or electrons or whatever you via model ID, please make alarm, and we will try to improve this part of the code.
In part, this, I guess, was not to do with EM physics, but to do with other things that we'll touch on in the next days as well. But maybe we'll have a chance to come back to it. There are 2 sub-bullets for this question beyond that. Is the polarization of annihilation gammas from positrons at rest implemented in default by Geant4 now?
Yes, in recent versions, by default, gammas are polarized in any annihilation.
And the final sub-question of this one was, for PET applications, do you suggest Geant4 EM standard option 3 or 4?
For PET application, probably option 4 is the best.
Okay, and there's a few more questions about cuts, which were from yesterday, but maybe I'll pause and see whether there's any questions from the room. So the first question yesterday, which we missed, Matimos was behaving very badly. So the questions came completely different time than they were posed. Could you explain what it means when a cut, a protection threshold, is in terms of length?
Yes, I tried to explain yesterday. I tried to explain today. I will repeat a third time. What means cut in range described in millimeters or microns or whatever? Why we do this? Because the task of simulation is provide radiation field, how radiation interacts with matter. And radiation field you need to know with some special accuracy. It is your requirement. Your sensitive elements or your material which are under radiation. You want to characterize radiation effect in space. It is why our cut is in cut in range in units of length. It is your requirement for accuracy of simulation. Internally, we transform this into production threshold.
It represents the distance that a charged particle will go, the maximum distance of a charged particle, other than fluctuations, how far it will go. So you will not produce particles that go less than this. For neutral particles, maybe though you need to say a bit more.
For neutral particle, it is there is this limit is 5 times more than mean free path for a given energy. Because neutral particle do not have fixed range. It is distribution according to exponential law. We need to make a decision what is the range in this sense. But you have infinite exponent. It's not finite range as for charged particle. So we use 5 mean interaction lengths.
So the next question has to do with the energy threshold for protons is defined the threshold for the kinetic energy of a nuclear recoil. Does this mean that during hadronic elastic interaction, all hadrons are always produced independently of the proton range cut?
Of course, they produce independently. We only apply this cut for proton in order to decide whether we create G4 track for recoil ion or not. And usually it is question of elastic scattering, but this physically connect with the task of simulation of radiation damage for devices. For example, you have silicon, you have a particle which comes through. Do you create damage for crystal, for silicon crystal, when you transfer given energy to some node? And this threshold in kinetic energy connect with experimental fact that if energy transfer above something, you will have a hole within crystal. And it is, let's say, physical value which connects with radiative damage. So it is not arbitrary method to do not track low energy recoils, but these connect with real physics processes within crystals. Concerning this cut on proton, you easily can set it to 0. And the CPU will be more, but not dramatically. CPU strongly depend for cut in range on gamma and electrons, and weakly depend on cut on proton. You cannot put cut in range to 0 for electron in Geant4. Unfortunately, we will not handle this correctly, but you can do it for proton.
So, there's another question regarding cuts. You mentioned that it's yesterday that it's better to set cuts when you have a multi-threaded application using the UI rather than in source code. So the person asks if they're in empty mode and receive a physics list from a collaborator who set cuts within the physics lists, should I be concerned or set the cuts again with the UI?
Of course, it is choice of your application. In some applications, UI commands is not the main method to define parameters in general. UI commands are collaborative with multi-threaded mode. So you don't care if your command can be applied, you issue this command in macro file and will be correctly handled either in master thread or in all threads and will be correctly used. If you implement the same in C++ code, you need to know what you are doing and implement this correctly. You have usually most of Geant4, not only electromagnetic, but other commands have equivalent public interface when you can set up a C++ command for given parameter. It is possible, but when you do C++ definition, you need to be sure that you do this in correct moment of initialization, because it may be overwritten by another part of Geant. It may have no effect, for example. Or you set it in master thread and it is not propagated to worker threads. So here, if you do it via C++ interface, everything is possible, but you need to be much more accurate. In UI command, Geant4 service do things for you.
Thank you, Vladimir. I think we can move on to the next talk. It's about multi-threading, and we'll touch a little bit upon aspects that have to do with it in that, and we can come back to it if people have any follow-up questions. Thank you very much.